Let's talk for a moment about strategy when we're going to work a polarization problem with several different layers. So for example, here I just had 2, but I could have 3, 4, or even more layers of polarizers. The first thing is to work through the system sheet by sheet. We start with 1, we look at the very first one we encounter, find out what that polarizer does to it, and ignore all the later ones. Then when we get done with the first one, we treat whatever has come out of the first one as what goes into the second one. So at each different film, we find the intensity transmitted by any sheet, either by applying the 1/2 rule, if it's unpolarized light going through a polarizer, or the cosine squared rule, depending on whether the light that reaching the sheet is polarized or unpolarized. And the light that comes through a polarizer is always polarized parallel to the polarizing axis of the sheet. And then whatever comes through we know is polarized in that direction, and we just go to the next sheet and work from there. So let's consider this problem. I have 3 different polarizers. I start with unpolarized light. It goes through the first polarizer, then the next polarizer is 60 degrees from the first one, and the next polarizer is 90 degrees from the original one, or 30 degrees from the middle one. So let's find out what each of those intensities are. First, we consider just going through the first polarizer. In that case, I started with unpolarized light. I get polarized light, and I know that when I go through a polarizer the first time, I always get that the light coming out, I1 in this case, is the light coming in, I0, times 1/2. Now for the light going through from I1 to I2, that's going to be I2 is equal to I1 times the cosine squared of the angle between those, which in this case is 60 degrees. Cosine of 60 degrees is 1/2, so that's simply 1/4 of I1. I1 is 1/2 of I0, so that's 1/8 I0. So it's less, but it's certainly not 0. Now let's figure out the intensity coming through the third one. Now you're probably thinking, Dr. Leverage, it's obvious. This one is 90 degrees to the first one, so it's going to block out all of the light. Wait a second. This polarizer caused the light to be polarized parallel to this axis. So now I3 should be I2 times the cosine squared of the angle between the second and third polarizers. That is 30 degrees. Well, the cosine of 30 degrees is √3 over 2, which is going to be squared to give me 3/4. So this is 1/8 I0 times 3/4, and I get 3 30-seconds I0. Now it's a small amount, but it's definitely not 0. Putting this filter in between the other two actually allowed more light to pass through than not having it there. And I will show that demonstration for you in class. Let's talk just a bit more about why that happens. I'm going to copy this, make a new sheet, paste it down. I start with electric fields pointing every which way. As they come through the first polarizer, I'm left only with electric fields that point up and down. Actually, let me use it. Different color. So the electric field is strictly up and down. Now you'll notice that electric field has no component along the x direction. All of it is along the y direction. But I could also break this up along a curved axis, or a tilted axis, which is exactly what I do here. I take it and break it up along an axis that's tilted at 60 degrees. Notice now, this component that's along this axis, that's a component of this electric field, but this component itself now has a component along a horizontal axis. By taking components of components, we get a component that is 90 degrees from the original. I can take a component of this component, and it will in fact point along the x-axis. This is actually nothing new. You've had experience talking about balls rolling down hills. Now, when a ball rolls down a hill, it has to move to the right, along the ground. And yet we know gravity has no component along the horizontal. But by taking the component of gravity that is down the ramp, and there is a component of gravity down the ramp, then that component down the ramp has a part which is horizontal. It's the same basic idea.